Okay, today we will look at the question number 3, which is 3a. And the question asks, if sine theta is equal to 1 over 4 and the theta is greater than pi over 2 and less than pi, find the cos to theta. Okay, the first information given here, which is the range of the theta. The theta is greater than pi over 2, or we can exchange it by the degree unit, which is 90 degree, and pi here will be 180 degree. Then we can conclude that theta here will be in the second quadrant. Thus, we will just conclude the information which is sine theta, which is so opposite by hypotenuse 1 over 4 here. Thus, the SM015 here we will get by using the hypotenuse formula. Thus, we will get the value of cos theta, which is a negative SM15 over 4. Then sine theta is equal to 1 over 4. We must remember that the cos theta, whenever it in the second or third quadrant, the value of cos theta will be always negative. Thus, we will look at here. By using the double angle formula, we will get that cos 2 theta is equal to cos square theta minus sine square theta. Thus, we will just replace the information here, cos theta here, negative 15 over 4, and sine theta here, equal to 1 over 4. Thus, we will get the 15 over 16 minus 1 over 16. Thus, just conclude it, then we will get cos 2 theta is equal to 7 over 8. Then the question wants us to find the sine 2 theta. Again, by using the double angle formula, we will get sine 2 theta is equal to 2 sine theta cos theta. And again, we just replace the information sine theta and cos theta, and we will get sine 2 theta is equal to negative 15 over 8. Okay, next we will continue with the question 3b. Given t is equal to tan theta, show that tan 2 theta is equals to 2t over 1 minus t square. If we look at the double angle formula, we will get tan 2 theta is equals to 2 tan theta over 1 minus tan square theta. If we using the left hand side, which is a tan 2 theta, it will equals to 2 tan theta over 1 minus tan square theta. After that, we just substitute t into the tangential, and then the final answer will be 2t over 1 minus t square. And the final answer here will be proven. After that, hence solve 3 cos 2 theta plus 2 sin 2 theta minus 3 equals to 0 for theta is greater than or equals to 0 and less than or equals to 2 pi. Whenever we made the hence word, we must remember to use the previous answer, which is tan 2 theta equals to 2t over 1 minus 2t square. After that, we just draw the tan 2 theta triangle to get the hypotenuse here. Because tan 2 theta is equals to opposite by adjacent, then we must draw the triangle so that we will get the hypotenuse here which is 1 plus t square. The reason why we need the hypotenuse here because we will use it for the cos 2 theta and sin 2 theta, and thus from that we will get the cos 2 theta is equals to 1 minus t square over 1 plus t square, and also sin 2 theta is equals to 2t over 1 plus t square. Then we look back at the question. The question is 3 cos 2 theta is plus 2 sin 2 theta minus 3 equals to 0. Cos 2 theta and sin 2 theta here we just find, which that we just replace it. After we replace cos 2 theta and sin 2 theta, we will get 3 minus 3t square plus 4t over 1 plus t square minus 3 is equals to 0. If we want to conclude the number 3 into the calculation, we must equals its denominator, which is 1 plus t square, like here. After that, it will be 3 minus 3t square plus 4t minus 3t square over 1 plus t square equals to 0. After that, we just calculate it. It will be like here, which is a negative 3 square plus 4t over 1 plus t square equals to 0. After that, we just move up the 1 plus t square to the right side, and it will be 0. After that, will be the negative t square plus 4t equals to 0. And if we want to remove the negative sign here, we will remove whole left side to the right side. And because of that, it will be 6t squared minus 4t equals to 0. After that, we just simplify it to the simplest number, which is 3t squared minus 2t squared equals to 0. After that, we just factorize it by t, and it will be 3 multiplied by 3t minus 2 equals to 0. And we will get t is equals to 0 and t is equals to 2 over 3. And if we remember, it means tan theta, and tan theta will be 0 and 2 over 3. After that, we will use the tan theta value here to find the range of the theta, which is theta is greater or equals than 0 and less than or equals than 2 pi. First, we look at the tan theta is equals to 0. So remember, whenever tan theta is equals to 0, the only x-axis will, or theta axis equals 0 will be 0, pi and 2 pi. Because of that, theta or x here will be 0, pi and 2 pi. After that, if we look at the tan theta is equals to 2 over 3, we will use the basic angle, and then we will find it shift tan 2 over 3, and the final answer will be 0.187 pi. After that, if we use the range here, range of theta here, we will get 0.187 pi and 1.813 pi. And the conclusion will be, we conclude the all theta here, and we will get a 0 and 0.187 pi, 1.813 pi, and lastly will be 2 pi. And that's all from me.
Question 2a. The polynomial px and qx are defined by px equal 12x cubed minus px squared minus qx plus 8 and qx equals px cubed minus 4x squared plus qx plus 20. Find the values of p and q such that x plus 2 is a factor of px and qx above.
So to find the values of P and Q is by, since x plus 2 is a factor of Px and Qx, so use factor theorem, Pa equal to 0. Pa is x plus 2 equal to 0, so the value of x is negative 2. So substitute value of x, which is negative 2, into polynomial Px. So substitute negative 2 into Px, and you will get negative 8p plus PQ equal to 176. So you get equation number 1. And then you substitute value of x equal to negative 2 into Qx. So you will get negative 8p minus 2q equal to negative 4, which is equation number 2. So you can solve the two equation by use elimination method with equation number 1 that we just multiply with 2. So it's going to be negative 8p plus pq equal to 176 minus negative 8p negative 2q equal to negative 4. So you will get q in equal to 30. Substitute q into equation number 1. So you will get negative 8p plus 4. You change the q into 30 and equal to 176. So p is negative 7. So therefore the value of p is negative 7 and q is 30.
2b. Given mx equal x cubed plus 11x squared minus 5x minus 7 is divisible by x minus 1. First question. Find all the root of mx.
Okay, the question want us to find the roots of the x. Okay, from the here, we can know that the mx here is divisible by x minus 1, which is if we can do one method to find the quotient here, which is using the long division method. Then we just use it to get x plus x cubed plus 11x squared minus 5x minus 7 divided by x minus 1, and we will get the final answer here will be x cubed plus 12x plus 7, and the remainder here will be 0. After that, we use the formula mx is equals to x minus 1 and x squared plus 12x plus 7. And after that, we vectorize x squared plus 12x plus 7, and it will be like here, which is x plus 6 plus 29, and x plus 6 plus minus 29. And from the here, we can get that x minus 1 when we equals to 0, and the final answer will be x plus 1, x equals to 1. And when we x plus 6 plus 29 equals to 0, and the final answer will be x equals to negative 6 minus 29. And also here, when we equals x plus 6 minus 29 with 0, and the final answer here will be x equals to negative 6 plus 29. And after that, we will get the roots, the final answer here. Okay, the second question asks about the zeros. Using the previous answer from B to B1, layer root equals to x equals to 1, x equals to negative z minus z 29, and x equals to negative 6 plus z 29. We just remove the x to get the zeros, which is the zeros are 1, negative 6 minus z 29, and negative 6 plus z 29. And that's all question to be.